Let xn be a convergent sequence of real numbers, and x1 is greater than pi plus root 2. We know the value of root 2 is 1.4 something, and xn plus 1 is defined as pi plus square root of xn minus pi for n greater than equal to 1. Then which one of the following is the limit of the sequence? Means we have to find the limit of this sequence xn. So as you can see, limit is around pi. So limit value is surrounding the pi or maybe pi, but all options is related to or somehow around pi, so we cannot directly put the answer by intuitive way. So we know the two concept. If xn is the sequence and limit of this sequence is x, then if f is any continuous function, then limit of f of xn is equal to limit of xn or fxn tends to fx. So this is the one concept you can use here. And second one is if limit of xn is L, then limit of xn plus 1 is also L. So we have to use these two concepts here, and we will try to find the limit of this one. As x1 is greater than pi plus root 2, and value of root 2 is 1.414, or you can say around 1.5. So x1 is greater than pi plus 1.5, or approximate greater than. So you can find x2 is also, because 1.5 is given, and x2 can be easily find out by pi plus square root of xn minus pi. A scientific calculator is in your exam portal, so there is no hardness to find the square root of some typical values. So you can easily find the values of x2 as x1 is around pi plus 1.5 minus pi, and you have to take a square root of this value. So pi minus cancel out by pi, so 1.5 as square root, value of square root is 1.5, and value of square root is 1. So this value is value of square root of 1.5 will be 1 point something, maybe uh, 2, or so value of x2 is uh, you can consider pi plus 1.2, and you can see this is a decreasing sequence, as x1 is this and x2 is this. So you can say that x2 sorry, sequence is decreasing, or you can judge better. But we have to find limit of the sequence, as x n plus 1 is given pi plus square root of xn minus pi. So as I discussed earlier, limit of xn is L, then limit of xn plus 1 is also L. So limit of xn plus 1, you have to take both side. So limit of pi plus as you use the limit of sum is individual limit, and this is the limit of square root of xn minus pi, and you can take limit within the square. So this one will be limit of pi, this is constant sequence, so limit is pi, and limit of this expression will be limit of xn minus pi, and limit of xn is also L, so L minus pi, and this was in square root, so pi plus square root of this value, and limit is xn plus 1 is also L. So you can solve this expression to find the value of L. So this is a equation in terms of L. So you have to take L minus pi, and value of this is L minus pi, means you have to transpose this term, and to remove this square root, or you take square both sides, so L minus pi is square equal to L minus pi, and take a square, expand this bracket, so L square plus pi square and minus 2 times L pi equal to L minus pi. So this is the value, and you have to find the value or limiting value of this one. So, or you can write this one as, this is L minus pi. So you can take L minus pi as a common. So L minus pi is square minus L L minus pi equal to 0, and take L minus pi as a common. So this one is L minus pi minus 1 equal to 0. So L is equal to pi, and L is equal to pi plus 1. So we have two values of limit, but we have to identify, because the limit is unique, so limit may not be 2. So as the limit we obtained as pi and pi plus 1, as this is decreasing and we never got value of, because all terms are somehow greater than pi, so limit will be greater than pi. So this one is true, because in uh, earlier or starting point of this video, I have stated how this sequence is going to decreasing terms. So you can say that limiting value of this sequence is pi plus 1, not pi.